Is there a microphone?
Should be fixed now.
Okay, good, great, thanks. So what are these essential characteristics of clouds or something as a service? And these are again from the NIST document in America. And they say it has to be an on-demand self-service. It has to have broad network access. It shares resources. It's rapid elasticity, so if you need more, then you get it. And you have to measure the service or being able. So that are the characteristics of a cloud in their idea, but also related to something as a service. So keep these things in mind. Then about how does that position network as a service, software-defined networking and OpenFlow? How does that position a little bit together? I think that there were other people yesterday who were more or better able to explain that in some way. But for me, there are a few things that at least I picked up. I think OpenFlow is just a management protocol for making forwarding tables. Not that I invented this one. This comes out of another presentation of somebody who knows quite a lot. I think I have the URL later on the next slide. But it's a very technical thing. It can change the forwarding table. It is a very technology-driven thing. It's not really a service. It's not something that you want to give to end users, I think. But it is a technology that is very handy, because you can make your own routing protocol and whatsoever. It's for me like an IP router. I have an OpenFlow system that can also do things. Now SDN, I think, makes that an abstraction. I think that came also up in the meetings or the presentation of yesterday. It tries to abstract the control plane. I think that is the most important. So it sees things more in an abstract way. And then, of course, you have to do all these technical things below it. But it abstracts the network and the control of the aspect. Now, network as a service is in some way the same, I think. It tries to integrate things, virtualize, and it is service oriented. So you have to abstract to make virtualization possible and to make it service oriented, in my opinion. So there is a kind of overlap between software-defined networks and network as service, but there is some difference. Don't ask me which difference. I'm just getting used to all these terminology also myself, but for me, they are very close. I think that SDN will also provide a service because that's what they want to do. But it looks that SDN is more a technology-driven idea, while network as a service is more looking from the service side. But I think they can come together, and certainly looking at the methodologies and the protocols and the interfaces they use, they can come together, in my opinion. So there is not much difference, in my opinion, between SDN and network as a service. SDN is from 2009, I understand. In my opinion, network as a service is from 2001, when we started together with the Canadians to start using something as network as a service. Here is another slide about SDN, and I think these give a good idea of the flexibility of what software-defined network can do. A network as a service can do that also, if you provide the right interfaces to it. But this is at least the design access that I understand that SDN provides. So it can do centralized or decentralized control. At least that should be part of their thinking. It's microflows and aggregated flows. That is all possible in SDN. You can have reactive forwarding, that you know that you don't know where a packet goes, you only know it when the packet arrives, or you do it proactive and then already the forwarding tables are done properly. It can be physical or a virtual system, and it is a fully consistent state, so at the start you know the whole system already, or you don't know it at the start of when you start with the service. And in principle, SDN allows for all this flexibility. There are, BGP is in principle a decentralized service, and that's only a decentralized service, because every router decides for itself. But SDN will allow that is more flexible, and so you have more flexibility in the whole concept. And of course, you need a lot of software and so on to do that, but at least it gives you a lot of flexibility also. I think that's where we want to go to with networks. So why network as a service? Because I said already, an IP cloud, if I check these things, what the cloud means of the NIST definition, I think an IP cloud, it's in my opinion, an on-demand service and self-service. I can put a packet on and the packet goes an amount. It's broad access. Everybody can do it in the world almost. You pool the resources because everybody uses the same systems or links or routers. You can just put more bandwidth in it if it is there, of course. Yeah, there is a limit, but in some way it's a very elastic system, and it's measured. Sometimes you measure it on capacity or in the bits or whatever. But for me, an IP cloud is a very good network as a service, and we should not forget that. I think an IP cloud is very simple to make, and it works for most of the applications. So I think that's why we are so successful as network providers to provide services to all these different applications. So don't forget that we have a very good cloud, in my opinion. But I think there is a but why we are working on this idea of network as service. I think at the lower layers there is no flexibility. It's very static and so on. I think that's what we want to change. Why an IP network can't do that? I think there's always that question: why do you need a lower layer link? Good quality of service, end-to-end delay might be reasons why you want it. And of course, you want to do it at the same flexibility as an IP cloud. Perhaps more flexibility in routing. So the net flow ideas, technologies, you want to incorporate them, or the SDN design matrix. You want to give that more flexibility. And we want to give these future applications the possibility to dynamically change the network below them. Because at this moment, more or less, if Google has their software as a service or infrastructure as a service, the network is very stable. If they need more bandwidth, it's very difficult to get at a certain moments that they need more bandwidth at the service, at the software level. So it would be nice that they could ask more bandwidth when they need it. And I think there is the nice thing that you can incorporate software as a service, infrastructure service, and the network as a service. And you see a lot of Googles and Amazons are also working on that environment of SDN and network as a service. Hopefully, network as a service will provide good connectivity, secure VPNs, and so on, and perhaps energy consumption reduction. But I don't know if that will be really the case. I think a big change in all of this is that in the past we see a network, a link, and so on, and I think I see them now as resources. Yeah? And of course a network, a full IP network, is a resource, don't forget that. But an interface itself is also a resource. A link is also a resource. A piece of fiber is a resource. And the idea of network as service is more or less see all these kind of items that you make a network of as individual resources. And that you can group them together as a new resource, as a network resource, and that you're not interested in the internal ones, but it is that flexibility that you can say, I want a fiber, for instance as a NOC of an NRAN, I want a fiber there, I want an interface, I want a router, a switch, and I want to make myself a network so that my users only see a network. But it is that kind of flexibility that the whole idea of network as a service will provide, that you can say, I provide the whole service to an end user, but for a NOC, I only provide the individual resources with the same methodology, the same interfacing, the same GUI perhaps, and so on. Again, this is not something that will be implemented tomorrow. It's a future view, but I think there are possibilities now with the present software and ideas that people have. So all these resources. And normally people always see these resources as the technical resources, servers, routers, links, interfaces. I would say don't forget the human as a resource. The human is at this moment still essential to design a network. So a human as a resource is for me important, and I think any system that we design should include a human resource. Yeah? I'm not saying that you should not automate resources, but certain things are not automatable yet. designing an IP network or designing a fiber network over the world is not automatable. You have to know where the fibers go and so on, and you need a lot of human intelligence. So don't forget human resource in the whole system. And there's a good example. Amazon provides that service even. It's called the Mechanical Turk Worker, where you can provide your service as a human. You get even money if you do things for other people. So, and we could also utilize that if an interface has to be installed in a router, the whole system says, okay, interface has to be installed. I give a piece of work to a human resource, and that will install the resources. Perhaps the delay or the time to implement is depending on who does it. Yeah, if the machine does it, it's perhaps faster than a human, or the other way around. I don't know. Depends on what you want. So make sure that is in your thinking. I don't know how to integrate them yet, but we have to. It's possible. We have web services. Humans are able to read web services, or at least web pages. They know how to react on things that other people ask you, or machines. So, and certainly with all these mobile things, we know that if a message comes in, we know what to do. So I think we can integrate it now. As I also said, it's not only what you want to do with the network, so transport data or get the video working or that kind of things. No, it's also about managing these resources now. And in some way, I also want to see the management of the resources as a resource. Yeah, so it's a very iterative process. A router resource needs management. You have to configure it. That's one type of resource. You have to react on faults. You have to get reporting out of a router. And all that kind of things are also, again, resources. Why I want to see them as resources, the reason is that I want to give these resources to somebody to manage them for me. If I have a router, there is security. Normally, perhaps I don't care about security, but the computer center director in the institute cares about security. So in some way, I would like to have a system where I can say, here are the security aspects of this service. Give it to the computer center director and let him manage the security aspects of my service. Of course, there can be human conflicts between them, but at least I made sure that I can, how do you call it, partition certain aspects and give it to other people. Again, this is not yet implementable, but it is the next step I think that we should go. Another concept is the management of the resources, that in some way that they become a user problem. Lots of people won't like that, I think. So if I get a resource, it's almost like buying a house. Not fully, all examples go wrong, but if you buy a house, I become, or if I rent a house, I become responsible for certain things to keep the house running, because I get some maintenance that I still have to do. I could say, I don't want to do that maintenance, but I give that maintenance to a maintenance company. So, but still I'm responsible that there are no leaks in the house. I still have to look after that, and perhaps I don't want to repair it, so I give that piece of work, that resource, I give that to somebody else to manage that for me. And so it's but I own the house. It's a single domain. It's my house. Although perhaps I don't own it, but I live in it, so it's becoming my house. So it's in some way it's a single domain. The only thing that I do is that certain parts of that domain I don't want to manage, and I give that to somebody else under my responsibility. So there is no multi-domain problem in this environment, which is a strange step perhaps. Somebody owns or rents or gets resource. There are certain management properties to that, and you have to make sure that they are done by somebody, and you can give that away to somebody else. An example, an NREN buys all the equipment, and normally they also want to do quite a lot of management aspects. Yeah, they want to look at faults, first line faults or second line faults. So we want to do that as the end-to-end NOC. But we don't want to do the third line maintenance, and we give that to somebody else. Yeah. But it is that flexibility that I want to automate in some way. Yeah. But it becomes a single responsibility. And I think that view is a little bit different than we had in the past. Now, types of resources are already discussed. There are the management resources. There are the FCAPs, so fault, configuration, accounting, performance, and security. These things have to be done on every resource that you have. Again, you can keep that work to yourself, or you can outsource it to somebody else, but you stay responsible for it. Somebody said standardization, very important. To be honest, there is no proper standardization on all of this yet. The Amazons don't talk with the Googles on the software as a service or the infrastructure as a service. So we have to work on this, and I think Manticore and other people are looking at the OGF, the NSI, or the ISOT groups, the DMTF, TMF, and ETOM. I think they all have to come together to make sure that this something as a service will work, and in such a way that you can indeed move from one supplier to another supplier, and can outsource functions in a generic way. It's a very futuristic vision, again, as I say at the beginning, but I think if we don't work in that way, then we will never come there. So, the Danish cloud. Here we see me playing with these two things which I grabbed from the airport. I think I stole them from the airport because I had forgotten them to take them from home. But a cloud and the whole principle, I want to tell an analogy. So we have a cloud. Lego has a very good interface. It's standardized. There's only one interface. It's only this little stud, I think it's called. And with that single thing, you do everything. Yeah, you put things together. That's it. Nothing more. It's defined. It's standardized. Perhaps not in a European standard, but Lego at least standardized it, and I think only one company is allowed to do it. You know? So if we would see our services as these kind of blocks, and here are a few examples because I will build on these examples. And again, I see management resources again as a small piece that I can give to somebody else. And I see them as smaller. The one with one stud is a management resource. And you see that there's also a human there. It can be a human who does the management for me or who makes something for me work. And we have, of course, it's a simple thing that is based on links or air or mobile and so on. So I go to the marketplace because that's the other principle. There is a marketplace where you can buy these kind of things. And you choose and pick from that marketplace your things, and this is what I want. There's some IP pieces, some fiber, some air pieces, some Ethernet pieces, and that's what I have. And there's even a video application, the one with the window. And there's a human to help me design a lower layer network. So there's a video, and I hope that my time of talking will help, I don't know. But we have fiber resources, that's what I bought. There will be some fiber, it can be multiple fibers, but I have it. Beside that fiber, I also want to, for my application, some air people doing mobile things, so I need to do some Wi-Fi or whatever at the lower layer. And I need somebody to design it for me. I can't do that myself, so I do that with somebody who will look at the coverage for my network. Then I do an Ethernet layer on it with multiple switches, whatever. Perhaps I can do that. At this moment I do. But there is also a management interface needed because I have to make VLANs and so on, so there will be an Ethernet management. Put an IP layer on it, multiple switches, 3 in this case, I see. And I put in a video application on that, which has, by definition, at least an application, a management interface, where I have to say yes or no to start a video. So it is all built on a single interface in some way, nothing more. And I think that's what network and infrastructure service and software is thinking, making it one interface that is easily accessible. I think the TMF is working in that direction. It's all a lot of overhead because you have to control that kind of things, but I think everything that we are doing nowadays seems to increase the overhead more and more. So that's the vision. Can we build application services in this way with using the product that is made here in Denmark? Now, in the Montecore project, we are doing something like that. We are looking at a network as a service, as making that in this way that there are resources that you can build them easily, and so on. And here you see that the whole way of what is done. The top layer is where let's say how you make a network. In this case it's IP network. So how do you make IP network? What are the rules about IP networks in a very abstract way? There are things that are, let's say, the more intrinsic way of how the whole network as a service principle works, or what are the interfaces and so on. And of course you have to determine the platform and how do you talk with the machines which are still at the bottom of the pile. And every machine still has a different interface. It would be nice that every interface talks the same language. If it is network as a service or SDN or whatever, I don't care in some way, but that doesn't work at this moment. Of course, there is not one machine language to configure, manage, and so on. Interface. So you need some specific pieces of software. I think in Autobahn you call it technology proxies, and now in a similar way you need these kind of things here. There are companies nowadays, I think TELEF here in Scandinavia is working at trying to integrate that kind of things. There is a single CLI more or less. So it's all working in that direction. You have a high abstraction layer, and at the end you have the bottom. And at the top you know what the network is. You can also put a human, by the way, at the top to make sure that that you get the network that is perhaps not yet implementable or not yet implemented in the piece of software. So the use cases, because you always come back to that, what are the use cases for such a thing? In some way, HANet is looking at making a virtual client premises equipment. I'll come back to that, what that means, but that is reducing the number of boxes in our network. I'll give some more input there. The other idea is also, the clouds. You have the hybrid clouds, which are a combination of private, community, and public clouds. You want to move your applications around these different type of clouds, depending what information you want, or perhaps because it's cheaper to go to another one. Your network should move with that automatically in some way. That if you move your VMs to another location in the world, or you want to have them closer to yourself because for privacy reasons, that idea of moving the services with the network is another use case, and Grid Ireland and Nordinet are looking at that as part of the Montecore project. The other thing is also you have a piece of network, or at this moment, in the case of the Danish health network, there are 2 routers managed by 2 different people. And it might be that it is possible to move these physical routers, or make it one physical router, and have 2 people access to it for 2 different type of services. One for the academic network, the other one for the health people to manage part of the router and part of the services. And I think we're also looking at multimedia high-speed applications that you generate the links when people want to see a video. But I want to go to that virtual CPE premises equipment. The virtual CPE premises is the router that normally, in our definition, the client has. It's very close to the client network. It's normally, certainly in the universities, managed by the university and connects to HANet. That's a little bit the principle. So you see here the principle that this is the router of the client, and it is the border system. It could be a switch of us if HANet has a machine, but principle is the first IP router that is connected to the HANet core router. So this is the present method, and we have resilience. So that's why there is always two things of everything. That's the reason why you see a gray and a blue one. So what we're thinking is removing that router from the client and make that virtual routers in HANet routers or HANet service. And in principle, we have now removed these routers, and there are now, let's say, routers that have these aggregated virtual CPEs there. That CPE is still the responsibility of the institute. Perhaps we house it as HANet, but the institute still has the responsibility to look after the routing tables and so on, or the ACL links, lists and so on. So there is a shared responsibility. HANet will manage the physical hardware, and perhaps they have to do a little bit more because the client asked us to do a little bit more. They outsource the resource to HANet. But a client still wants to do certain things on that router because there are local functions on that router, because they could be connected to other IP routers that are further down in the client network. So you see here a shared equipment by two parties, and it is reducing the equipment. So we hope that we can reduce the cost, the energy consumption, that kind of things in this environment. We think, but we are not sure, that, let's say, the 3 clients could be shared on one physical box. So it's 1 in 3. That's the idea. So I don't know if that's economically advantageous. That's what we are going to investigate in the coming time. So we want to virtualize that, and of course, we have to make them virtual. So you need equipment that can virtualize the routers. There are some routers that can do that. You have to configure them. You have to make the links between this because the network changes, as I said, and you have to delegate that partial control to the user, and then, of course, with a nice interface. Now we can learn there from what we did on the layer 2 in HANet. We have a point-to-point connections tool. It's called BlueNet. We have some 500 active connections at 1 gigabit level. You just point and click at the end of the network, and it makes links over MPLS or normal native Ethernet networks. And so it's an interface. It works. It's accessible by web services. It's a GUI, whatever you want. So it's easy. You have an automatic inventory, part of the management, automatic monitoring. Yeah, you get directly the tools for monitoring all these kind of links and so on. And even other people can access our point-to-points now, like the bandwidth on demand is, because in principle we don't provide this service. We provide in HANet this young bandwidth on demand service. So it's one network in our case. We see everything as production in that sense. So we want to do the same on the IP layer, and that's where the Manticore project comes in, and then the software that makes that, which is called the OpenNAS, is exactly the same as the layer 2 provisioning system. In this case it's open source. You can do a CLI or an API. It's we have a nice GUI around it, and it is integrating the bandwidth on demand service. It could be any other service. It's just a technology, but we utilize bandwidth on demand because that's existing, so why not use existing things? So I have no live demo if wanted. If people want to have a live demo, they should have been here last week, I think, in Denmark, or 2 weeks ago in Ireland. But if people want to see a live demo, then let me know, then I can arrange for that. But what it did is, let's say we have 3 domains, international, and there's a user who wants to make a connection, an IP network over this infrastructure. So there are IP resources there in that network. You have to make sure that are being made links between these routers. You do that with the Xeon bandwidth on demand, and then at some moment you can make the video work. So it's comparable to more or less the demo I did with the Lego. So it's all futuristic in some way, but it's still realistic, in my opinion. So we get experience with this concept of something as a service. We want to integrate the network as a service with the software as a service, the infrastructure as a service, and so on, that HCN is also investigating. We see resource management is something not really defined yet. I think in Geant we are the first ones thinking about that concept to make also management a resource. And we want to see how that evolves, looking at the idea of the market, that you can put your resources in the market and you can get the resource that you want out of the market. So it's all work in progress, but as I said, we want to utilize this service now in an operational or pilot environment in the beginning of next year. There are a few clients, at least in Ireland, that are interested to be guinea pigs, and hopefully perhaps in Denmark also, but we'll see. So that leads me to the last point. This is a labyrinth. There's only one way in, and you only get to the end of the life, because it's the life path. I'm not going to get a lot of going and throwing through that, but that's time for questions. I have not always the answer, I think, but we are on a path to life. So if you have questions, let me know. It can be now or later or whatever.
It can be now for sure. I have one.
Yes.
You had a slide where you showed different layers. You had the bot and the button. You had another layer, and then you had bot again. So was that intentionally that you sort of made hierarchical UD? You waited for somebody to spot it, or?
The problem is, I fully appreciate what you're saying. To be honest, it was hierarchical, but in principle, it should not be hierarchical. The whole system is not hierarchical. We are used to have, perhaps we are used to ISO layers, but I see them more as levels, but all the levels should be at the same level.
Yeah.
In my opinion. That I did it in this way is because I couldn't come up with a better way to present it.
Oh, but could it happen in principle that if you do something down at the bottom, provide a layer 2 circuit using any kind of whatever, then you build something on top of that, and then you create another layer, doing the same, that would be a bit, crazy, maybe, but it could happen in practice, knowing you don't have any control of all the networks.
No.
So.
No, true. And hierarchy is not, because in some way, as I said, it is you own the resources, so you determine the hierarchy even. And I decided to present it in this way. That was my decision. That if you want to do it in a different way, that should be possible.
I think it's. I agree that it could happen, especially when we have this multi-domain. The interface, but you don't know what it's going to be used for in another domain, and you don't care really, as long as you know.
And again, there is no multi-domain. There's a multi-domain ownership, but there is a single user domain. And so you have to separate. There is lots of theory around it, but there are different terms that you have to make sure that you can own the things, but you can also use them, and there are different levels. And perhaps there are hierarchies involved or not, but it should not be. Hierarchy should not be part of the system. That's it. You can impose it as a user, if you want.
Questions on this interesting topic?
I think in 5 years' time I will be still standing here, perhaps, and hopefully I can show that it works. Because I think the Amazons and the Googles, they just did it in 2 years' time. So
I liked your Lego analogy very much, and I don't think that Lego is standardized. I think that's
proprietary,
but there are some Chinese vendors that they can actually fit those building blocks on top of the Legos as well. Do you think that's going to be happening in the networking area as well?
I hope so. It should as long as it fits. It should be open.
So we just need to use them, and then
you have to start in some way. I think
you have to start somewhere, and then.
Because I think somebody said yesterday, there are so many projects doing this type of things. That's logical. Because do we know how to do it? So you have to do multiple things, in my opinion.
The Lego analogy is good. The patent has expired.
Is it? Okay.
And they're no longer suing companies that do
Okay.
compatible equipment.
So
if that,
So
if
that's
So
that-
after
in the-
60
in-
years-
it's an industry standard. Right?
Okay. Yeah.
Okay.
Okay. Thanks. Yep.
Thank you very much, Victor. Our next speaker is Mauro Campanella from Ghana. Play with the Legos.
Yeah. Okay. Let's keep it
Okay. I wish to thank Victor because it was a very nice introduction that allows me also to spare some of the slides. It's similar to what Victor just showed, but from a different perspective, in particular from a perspective of something which has been done during the last 6 years. So Federica was a European project which started in 2008. So we are talking about 4 or 5 years ago. Which were the principles? The principles was that using virtualization and putting together both network and computing equipment, you can provide the researchers an environment, virtual environment, which would be very useful for their research, especially if you do use virtualization in the current, in what we understand now. I will have the slides later. They can really become owner of a full infrastructure of virtual resources in which they can do disruptive experiments at all the communication layer. Optics is a separate thing. I have something later. Why these? Well, this is a requirement from the users, from the researchers. They don't want just to connect to the network. They want to own the network in some way, to play with it. As in depth as possible, obviously. What are the other main principles? Reproducibility. We never talk about reproducibility about virtual resources. If you are doing scientific experiments, then the experiments should be reproducible. Otherwise, you can't compare the results. Or at least you have to understand the systematic and statistical error that you are incurring. So, in some way, that was one of the key functionalities that we introduced. Does it work? I can't go in details now. Yes, it works almost for all the virtual resources. Complexity is obvious. And the other thing we wanted to do is that we do not want to reinvent the wheel. We wanted to use what is at our disposal now in terms of resources. This picture comes from Peter. He did it for a deliverable for the Federica environment. The idea is that, okay, we have a bunch of physical resources. Out of those physical resources, we create some virtual resources. We configure and connect them. We handle them to the user, and the user does what he wants. So this is a graphical representation of X as a service. We have infrastructure as a service. We have environment as a service, application as a service, whatever you wanted, the different layers. You can play with the layers according to what you prefer, but I found this is a very interesting graph also because the provider is here, we are here, the NOC essentially. The researcher is here because probably he wants to play with the resources, he wants to configure them, he wants to really do things, And then there might be upper layer researchers interested in application or the use of resources, but they do not want to configure IP. This kind of infrastructure I will show you exactly allows that. The terminology which you are using now is that this is infrastructure as a service, Federica, or testbed as a service. It depends on which type you want to look at. That was the original picture. So what we did, we took what is available now. We put some physical resources, and these virtual links actually are virtual links on SDH. They were on SDH. Combining them, you can create these virtual test beds and so on. Okay, vertical, horizontal, don't enter the debate now. It just means that what you create are really separate environments for each researchers. They do not communicate unless the researchers want to. Briefly, where are we now? The environment is still active. These are the current POPs in the network. We have 4 core POPs in DFN, GAR, TSMC, and SESNet. We are now supporting 3 large FIRE projects, Future Internet Research and Experimentation Project. This is topological view of the things. All the links were SDH and now are IP over MPLS. We tested the performance of IP MPLS, and I agree that given the fact that it's over-provisioned, there is almost no difference between a fixed capacity and IP MPLS capacity with the current infrastructure. Briefly, AES, MXs, Sun workstations with a lot of memory, a lot of things. The infrastructure, which I call substrate, the physical thing if you want, is a public AES with some public nets, and both IPv4 and IPv6. It's under test, but in practice is up and running. What is very important, I don't want to forget that, is that every element, which includes every virtual environment, every CPU, every memory, everything is monitored. We use the SESNet monitoring tool, and this is an example of what, as infrastructure provider, we had to do. We had to look at all the CPUs. Each machine has 4 cores, so this is 4 cores in one plot. So you can understand what's going on, you can understand memory access, you can understand disk write, and everything. At the end, it turns out that on the size of, I show you about 15 POPs, you have 50,000 elements to monitor in this sense. This is up and running. These are the 3, just to tell you what it implies, doing virtual infrastructures. Well, these are the 3 projects. Confine is wireless communities in 4 different countries. We connect them. Bonfire is clouds. We connect them too. And this is the Novi project, is a strap, and actually turns out to be the more complex one, because this is one of the 3 slices that the Novi project has, and each of that is either, these are the physical resources, if you want, and these are the virtual resources they are using and the mutual interconnection. The NOC is taking care of that. There is no tool that I know of that can easily handle that. We have some extensions. We are using open source software, but it's still complex, and I agree with Victor, standardization is not there. I've been asking to talk about, okay, but what is the architecture? And because I think we have to discuss about the architecture. Well, the framework thought from the beginning actually was based on 2 basic elements: computing and network physical resources and virtualization technologies. So this is the basic ingredients with which we built on. Without knowing the video from Victor, I also added Lego blocks, because a very nice thing. By the way, what Lego made the right way was the type of plastic. This is why the others don't fit very well, because I think that the type of plastic is still copyrighted. They found the right thing. So
Did you both discuss the Lego aspect?
no, absolutely. I use that analysis many times because it really helps to understand that we are moving to this kind of environment. And I have a final slide that also elaborates on that. Okay. We are not doing anything new. So the substrate has to have all what we are used to in terms of monitoring, NOC, AAI, security, everything. So it's nothing strange. It's just that you can do something more out of what we had now. I added that, then you can look that on the slides. Essentially, I think we have to discuss what virtualization is, because we are talking about virtualization. For me, at least, the virtual thing should have the same functional element, functionality of the physical things it wants to be like of. That doesn't mean that functionality is QoS, is the quality of what you get. You have to add reproducibility if you want something more. Okay. Usually they are done just segmenting things. Segmenting works well in computing, works not so well in router and switches, doesn't work in optics until now. Oh, recursivity is there still. You can't do it, unfortunately. So if you look at the architecture that we devised, and this is a proposal obviously, is that you have a substrate, and this is the real provider managed thing, and then you have all the virtual infrastructures as I show you. My proposal is that we should consider only two basic entities in the ontology. One is the connectivity itself, bits, and the other one is a computing element. This is a very strong statement, if you want, because everyone is used to think about routers, switches, network attached storage, various type of elements. If you really think at what they are done with CPUs, memories, and interfaces, and network interfaces, and nothing else. This is why it's possible to actually mimic a router with a PC, especially if you have very good interfaces. The software is there. Again, come back later. Resource description is what you immediately stumble upon. When you start dealing with this high level of multiplexity and scaling of number of resources, you have to have a way to describe them. Unfortunately, you have to describe them at all layers, which is not easy. So this is why a detailed ontology is needed. I don't want to do theoretical research, it's just needed. So we have to devise a good way to start with. What we decided to do is that apart from the internal database, if you want, we decided to have a slice federation architecture developed by Planet Lab as a way to expose resources to the other infrastructures, because actually SFA is made of two parts. One is the protocol to communicate and receive requests of resources, which is called SFA, and the other part is called the RSpecs, which actually describe the resources. The two things are complementary, and what we did, we took the SFA version 2.0 essentially, we extended that to describe our network. That's very easy because the way it's described is flat, each resource is extendable, you can even add another resource. So the basic functionalities of SFA are announce and request. You are a domain, you announce certain resources, and then you receive request. Is that all? Well, we are talking about architectures, right? So no, it's not all, because there are some hidden principles, if you want, that I wanted to highlight anyway. Meshing. If you really want that what you do behaves well, you have to have meshing. when you are not really capable of virtualizing something, you need to add resources. A good example is the network interface in the PCs. There is no virtualization there. So what do? You put a lot of interfaces. Is it good? Is it nice? No, it isn't, but it works. So this is also what I think we should think at. We shouldn't try to do the best thing possible. We should just have things that works in the right way. Over provisioning, of course, high availability. My estimate, and this is just a rough estimate between ourselves if we want, is that we had an availability of 99.5. Why this? Because no single element is such a poor availability. But when you combine on a large scale such a large amount of resources, then you are hit harder than normally. It's not just networking. It's also the computer. It's also software maintenance, scheduled maintenance. There is a lot of things that on a 5 years time scale, it hits. For example, we need to migrate the GN network. Scheduled availability is fine, yes, but it's unavailability at the end. So there are a lot of good reasons in which if you scale a wide area environment, then you lower, in my opinion, the availability, which is not the case if you have a computing center in just one place. That's a completely different environment. Okay. Standard protocols, yes, standard protocols are there. Network slicing can be done using any technology you want. You are using MPLS, VLANs. Should we use OpenFlow? Yes, why not? But in principle, this is not one of the key principles. It's just one technology to slice the network. Connectivity to internet. So I just want to go to show you that out of the model I showed you in the beginning, this is why the optical infrastructure is so important and is a key layer. I think that the presentation by Willy and Felix were very, very nice to really help us and to understand the complexity and the functionalities that we can get out of this. I think it should not be neglected as layer 0, so 0 doesn't mean anything. No, it's really, for me, one of the most key and important layers that we have to deal with in the future architectures. It gets even worse if you have to have an architecture that spans whole of Europe for GEAT. That's of utmost complexity to manage these kind of things. And this is, I think, a challenge we still have in terms of optics. The switching substrate is still there. I would call that the Frederica physical substrate is a mixture of switching and nodes and so on. That's still there, it's important. Okay? It where actually everything is. We create all the slices here, we manage everything here, we monitor everything here, and so on. Well, the virtual testbed is obvious. What I would just conclude out of the experience is that virtualization works for the requirement of the researchers and maybe also for ourselves. Virtual routers are an example. The key point is that just offering a bunch of resources to the user does not really help. This is where, for example, I slightly disagree with the business case, if you want, that Victor described before. You can't just put a bunch of Lego blocks in front of the user and say, please, feel free to use them to build what you want. They usually need instructions how to build something. My experience on a 5-year timescale with Federica is that it doesn't work. I actually put in front of the researchers a European-wide network saying, please ask us slices, we can configure them, you can play with them. Very, very few people wanted to invest their time in doing that and understanding the environment. So it's not as easy as putting Lego blocks. You need a manual at least, and you need an expert nearby. concluding remarks. I try to be very fast, but I hope that most of those was known, so I think so. Yeah, yeah. I wanted the discussion because this is the important thing. I would consider that what we describe now is not one architecture. Still, we are using a stack of architectures. For me, optics is an architecture. It's a very well-known, very complex things, and it doesn't mix with switching. Sorry, until now. I want to provoke a discussion. So, we have to think about stack of architectures and how to merge them in the future. If you're really willing to combine things, then we are still stuck at 2 layers. One is the optical layer, the other is all the rest. Switching, if you want. But we are still stuck with 2 architectures, or 2 layers. Resiliency is a good example of why we are still fighting between the layers, so between the architectures. Should we have resiliency in optics, or should we have resiliency in IP/MPLS, or in the MAXes? I've heard people saying, I prefer IP/MPLS, others prefer optics. So, there is a really need to decide, or is at least a need to reach an agreement according to the requirements? I think it's good that we have resiliency in 2. This is the reason why I don't like the IPv6. You just get rid of a checksum. I think it's wrong. I think the IP should have checksum as TCP and as Ethernet as CRC. It's much better to have resiliency in all the layers, actually. But you have to agree. The ontology is what is needed, and we have to agree on a very simple ontology to have multi-domain environment. If we want multi-domain services, no other way. We have to be clear on what we communicate between domains, to ask for something. Simple things, not complex things, but we have to agree. Especially not just the basic resource, but the characteristics of the resource we want to have. If you want the attributes of the resource. Federation is important. User interface, support, experience are the key components in the next years. We have really to be more careful in what we expose to the user as user interface. It should be very simple, very clear. So what's next? Well, I was thinking of that coming here and then also yesterday during the presentation. There is a lot of talk of software-defined networking. I suggest that anyone has a read of the slides that Nick McKeown, who invented it, had at the Infocom in Brazil in April 2009. They're really good. They really help you understand why he thought about. And he thought about these. Oh, now in computing, we are happy. We actually have a lot of competition between platforms. The platform has been standardized in Intel, so it's very common. We put virtualization, and then we can have any system we want and any app we want on any system. So this is really innovation. This is really competition between providers. We should have the same in networking. That was his original idea. It's not open flow. It's the fact that we have to transport that environment in networking in the same way, in which we should have a common hardware in which the providers compete, the vendors compete to have the same functionalities with a standard interface, no more Alcatel, Infinera and so on with a lot of headaches, but rather try to have the same thing like Ethernet switches, if you want. Virtualization is started with FlowVisor as an example, and then we can do whatever we want. So what we are talking about? I think we are talking about software-defined infrastructure, not networking. It's a little bit more than what he thought. And this is what I would propose, and this is how I understand things. I think that might be a possibility to evolve our networking. Otherwise, we will be stuck in a lot of unmatching layers in some way. The good thing that I would personally support also in this vision is that we still are at the horizontal layer architecture. And this is what I value a lot. This is my last slide. So, software-defined infrastructure. This is what Nick McKeown thought. This is how I see it in networking. Well, a router, well, why not a router or something that does a functionality, including network attached storage, cannot have a Intel CPU. This is something that works out of standard computing environment, fine. ASICs, yes. You need some power to switch things, to do things in hardware. We can't avoid them, obviously, fine. We will have some dedicated interface, very nice ASICs, everything you can think of. I added optics. Feel free to shout at me. Well, what's really the difficulty in having also a common optics, or an optics that you can play with? I understand the complexity of optics. We are going to the analog environment, but in principle, you may have FPGAs. You may have things that you can program also at the optical layer to do nice things. This is the common hardware. This is not OpenFlow. This is different. This is what we use to put together all these elements to create networks, to create infrastructures, to create other things. They might still continue to use the old protocols. There is no reason why not to use IP. There is IP there is OSPF, there is BGP. There might be more. Why there might be more and why it can be easier? Because this is software and nothing else. The hardware is here, but is compatible with clear interfaces. We don't have to compete between Cisco and Juniper. They should provide the same interfaces. It's up to us to use them in the right way. So you create slices, in each slices you can have virtual system, virtual router, virtual optics, whatever you want. Just to foster discussions. Applications are still there. I don't want to change the basic architectural principle. Resilience is there. All the other things are still there. Nothing really changed. Is this combination that enables you to do more, hopefully paying less, and with more functionalities. You are not obliged to use that, but you can do. Exactly like in this environment, you can continue to use Mac OS if you want, if Apple allows that, actually, because now Apple allows virtualization of Apple only on Apple hardware, so it's still a closed market. But in principle, this is the real idea behind that. We shouldn't get too complex. Actually, I hope that this is also a way to simplify things rather to make them more complex. Thank you.
Okay. Take a deep breath. And questions, please. Victor.
I think I like the idea of the horizontal layers in some way, but I think it's related a little bit to it's still the hierarchy, and I think for me an application is a resource because perhaps it uses a lot of other resources, but again it is becoming at the same level as even the hardware is being a resource. But in some way it is one horizontal thing. Of course, when you actually utilize it, you get these layers back. I agree with that. But for me, it is you make something, and then it becomes a resource, and you can give it to somebody else who does a lot of things with it that you don't know what he will do with it. So it's that iterative process, I think, that
I think is more complex. It's like building a house. For sure, you can build a house out of bricks, but then you can have also to put furniture in the house and put something inside the furniture. It is true that you have different providers of each element, but how to put them together is far from being obvious.
no, that's for me also easy because you get an architect in, which is a human resource to do that. And
I don't think it's correct.
A house is for living, and then of course you need a lot of resources to get it up to living. But again, you can sell that house furnished to somebody else to live in, or to rent it. So
No.
it becomes a normal resource again, and I think it's that principle.
What I'm trying to say is that there is no architecture on how to put furniture in the house in the best way. Everyone is free, correctly, to choose their own way of doing things. If you force an architecture, then, in my opinion, you reduce the freedom of doing these kind of things.
Exactly. That's why I'm saying.
So that is
don't
why
do an architecture.
Exactly. Exactly. But
okay.
you need to have these layers so that you can navigate and get the pieces out of that. That's the point. I think we agree.
Yeah.
But you need to understand how to do it. I mean, the shops should be in some places. You have to have a way to name the shops. So there are hidden principles here that allows you to use these, and this is what I tried also to highlight.
When you discussed optics FPGA, you said you can program these to do whatever you want. But
Yeah.
if you look at coherent technology today, just a nice thing about it, it's very tolerant against almost any dispersion method that's out there, and PMD, and without having the need to program anything. And isn't that just a nice thing?
I was thinking mainly at the framing rather than the detailed optical thing. I think that people may want to change the framing. One of the examples is between clouds. They need not TCP, because TCP is not segment oriented, it's not synchronous. And if you want a disk-to-disk thing, then you need synchronicity. And so maybe you want, out of a certain type of wavelength, certain modulation, which is done in a certain way. And so if you have an FPGA that allows you to do that, probably it's much easier not to think at Ethernet versus other types of framing more adapt to that or something, but maybe. This is the kind of freedom I was thinking at.
Stanislav.
Yes. More from application point of view and reproducibility. Reproducibility should be probably discussed in more details, because in such virtual system you will have reproducibility from application view, for example, in results of processing, results of data processing. You will probably not have reproducibility from point of view of time needed for processing. So
Yeah.
I think reproducibility is too general norm for discussing such things. We need to separate reproducibility of the
Yeah, I agree. This is why I say that reproducibility needs a complete discussion. What we were able to test on the environment is that you can really make a single virtual machine almost reproducible. You can make reproducible a point-to-point link and circuit. If you have a large environment of virtual resources, then making the environment or the whole slice completely reproducible, that's not easy to do. Is the standard QoS problem on a large area and on a large scale. That is not easy. That, in my opinion, can't be done. And this is also well known in virtual systems. When you have a very complex environment, it's very difficult to be reproducible. I agree. I think it's up to us to decide where to focus our effort and what really needs to be reproducible.
Yes.
Questions? More questions for me. If to me it's more like a theoretical architecture, and if you want to implement it, that's something different. And I remember in Federica when we defined the basic components in the substrate, when we picked the routers and the switches. Obviously, that decision puts some constraints on things what you can actually implement above us. But what do you think about this Genie rack concept? I think they not just describe the hardware, they give some requirements, a description of the software and other things above for measurements, for monitoring, for all kinds of stuff. Do you think it makes sense to somehow try and define recs of all this in some way and use them as a kind of implementation of this architecture?
I was discussing with Chip Elliott. Actually, even in Genie, they have at least 2 competing software parts.
Yeah, sure.
The hardware is there, then they have Orca, they have other protocols or other virtualization abstractions that they can use, and they actually don't want to choose one. I think that what is important and is even available, visualizable in the Nick McKeown slides, let me check, sorry. The fact that you have a common hardware and a common virtualization allows you to have virtual different controllers at the same time. So this is the beauty of this architecture. You are not forced to have a single architecture for a single controller. The controller can just leverage what's down, which is a very simple and thin virtualization layer and common resources. I think the same can happen here. I don't think, again, that we should have I don't think we have a single way to use these 2 layers, the virtualization and the hardware, to create in just one architecture these environments. This is why I wrote architecture 1, architecture 2. Why should we have the same architecture? That's not mandatory by the system. What is mandatory here are the interfaces between the different components.
Yeah.
And that's the important point. And the functionality internal that you can virtualize out of these bunches of hardware. But then you are really free to do whatever you want. And that's the beauty of it. Because in principle you can even provide the possibility to a user to create his own architecture. Fine. You just provide resources. Actually, I think that Federica does most of it. We are not in optics. That's not there. But this is almost there. Just because the Juniper operating system does not really allows you to use. If we go on with Juniper and use more of these APIs, then probably we're nearer to what I was trying to depict here.
I think even in Genie, there are, as far as I know, there are at least 2 different Genie racks done by 2 different vendors. One is HP, and I don't know which one is the other one. But they have at least some, as you said, some requirements as a common nominator somewhere at a higher level. That's what they require, and then the vendors can come up with their own solution, of course, that they have to meet
and be compatible.
Yeah.
Exactly, and this is partially is a Slice Federation architecture too, and our specs parts is these other interfaces. The interesting part, which I try to convey, is that now we are talking about software. We are not really talking about hardware any longer. It creates a lot of issues, headaches. I understand that, but nonetheless, we are shifting towards software as a way to combine things and do things, and this is what I think we should look at.
Questions, opinions, thinkings. Lunchtime is there.
Yeah.
Okay, thank you very much, Mauro, for this. Let's have a lunch break as we planned in a second, and continue in an hour. Plan to finish by 5.
10 minutes to 5.
So after lunch, basically, we have 2 more talks and a panel discussion. So that's as it is in the agenda, right?
We don't have it standard. Therefore, I asked the other, because we have at least 2 files, 1 page. Is it separated? The other, the 2 others, this is some other operators using this case, while you are the only just divide the bit management
How about a video conference? Because we have the streaming and the video conference.
Yeah, that's the best way to join. It's on the trade website, the details of the meetings.
And that's not there, but I can email. Yeah.
Do you have Jerry Sobieski?
Yeah.
He's good. He's good to send.
I email him the VCT.
Okay, thanks.
Fish and meatballs, that's
One more?